Hello, all the esteemed viewers. Welcome to my YouTube channel, Study with Aryan. And today we are going to study another complex topic that is actually complex numbers. Okay, so now as you guys know what is a complex number, I have already taught you what is a complex number. And if you are here on this video, so basically we are discussing all about properties, not a complex number. Anyway, let me just tell you what is a complex number just for your just for personifying it, just for defining it. Okay, now you can say a combination of a real and a imaginary part. Okay, now in here the imaginary part is my b, imaginary number is my iota, and meanwhile my real number is a. So a is a constant value that is used as example at a lot of places, such as in examples a square plus 2ab. So in this case, the a or b is termed as or valued as the, you can say, constant that is just defining the formula or defining the property in complex number that we are going to study right now. Anyway, okay, so I just told you what is a complex number. Now, what are properties? Now, what are properties? In total, we will study a few properties, including commutative. Okay, sorry. Okay, commu that is commutative property, dative, sorry, commutative and accusative property. Okay, so for now I have just typed these two properties and let me just tell you what are these. Anyway, what are properties basically? Now, properties are somewhat a asset of any particular term, such as if there's commutative, we will define it into its own origin, that is maybe plus, maybe minus, maybe multiplication, maybe division. That can be anything. Okay, but particularly at this topic, at this stage in 1.2, basically 1.1 was all about complex number, and this is about properties and all. That can be properties of anything, like properties of trigonometry maybe. Okay, so as we were talking about our first property, that is commutative. Now remember, properties only have two cases, that are addition and multiplication, nothing else. We are only talking about multiplication and addition in it. And if I talk about commutative property, it only deals between two. Okay, two, what, two complex numbers, not more than two. Okay, so let's just discuss what is an commutative property. Basically, commutative property that adds two um, complex numbers is known as commutative property. Now let's just discuss an example within it. Okay, now for suppose if there's value such as um, maybe, okay, 4 plus 3 iota, and the second value is 3 plus 4 iota. Now the thing I'll do is uh, like imagine this as my uh, complex number 1. Okay, and this is my complex number 2, the complex number 2. Okay, this is my second digit, this is my first digit, and if I do z1 plus z2, my first and second complex number, how will I do that? I'll simply add my real number with the real one and complex number with the complex one, and that will initially give me my left hand side, and similarly goes for the right hand side. If you have to find the right hand side, you will just jumble up these terms. You have to just do z2, like my second complex number, plus my z1, that is my first complex number. And that is how you will prove how to make them equal and what is a commutative property. Basically, at first, for left hand side, you will do z1 plus z2, my real number plus real number, then complex plus complex, not complex, but imaginary plus imaginary, then adding up all the complex numbers, that gives me answer of 7 plus 7 iota, and similarly on the other hand 7 plus 7 iota. Now that is quite simple, right? uh, Commutative is quite simple. Now, as I just told you at first of this video, that each case or each property owns two type of things, such as um, if a commutative property is there, then it will own itself in itself a addition property plus a multiplication property as well. We couldn't deny or decline that property because that is some more important or essential thing in this. Alright, let me just tell you what is an multiplication property in it. Now, as we are just discussing about what is property, what is commutative property, now we just discussed what is an addition property in it. Now, similarly follows for the second property, that is um, multiplication asset of this. Okay. Now, with multiplication, you have to just do one thing. You have to do z1 like multiply by z2, and similarly on your right hand side you have to do z2 multiply by z1. Now let's just suppose any value, again 4 plus 3 iota, okay, multiply by maybe again, okay, 3 plus 4 iota. Now in this place I will do a thing that I'll multiply my real numbers, then I'll multiply my real number with my imaginary, then I'll just do this, and similarly for this as well. That will give me a value of let me just type it, okay, 4 plus 3, that is not 4 plus 3, this is 4 multiply by 3. We are not doing addition, this is multiplication. 4 multiply by 3, that is 12. 4 3s are 12, and I'll add plus 4 fours are 4 iotas are 12 iota, okay, 3 iota 3s are, I'll just plus this 3 plus 3 multiplied by 3, that is 9. Sorry, I'll write 9 iota here. And if I do 3 iota multiplied by 4 iota, that will give me 12 iota square. Okay, and if I do 12 iota square, okay, iota and square upon it, that will give me minus 1. And if I do the same value as 12 plus 12 iota plus 9, and if I do this 12 multiplied by minus 1, that will give me minus 12. And after this you can just do a one thing, just simplify it and have your answer. And if we simplify or add it, we can have our answer as well. That is how simple it is. Okay, so after this all, you just have to do nothing, like literally nothing, and solve this up, like maybe 12 and negative 12 will give me 0. Okay, and this will give me plus plus um, and a plus. Okay, so that will give me um, a 12 iota. That is my answer. Okay, how simple it is. And similarly follows for the second case, whereas you will multiply the same value by its inverse. Okay, so that is how we cover commutative property of multiplication. I hope that's clear to you. Okay, now let's just discuss another property that is all about I can say assertive. Okay, like um, associative property, that was not accusative. Okay, I learned German. That's why I just remember accusative and dative cases. Sorry. So, associative case. Now, what is an associative case? Okay. Similarly, it has a plus and a division of minus as well. Not minus again. It's multiplication. Okay. So we will just deal about addition and multiplication here again, and similarly follows for the other cases as well. Okay. So, okay. Now, if I'm having such as okay, just write the formula of it. Okay, form of it, such as if I'm having now it is being dealt in three values, three complex numbers, z1, z2, and of course z3. Now you can do only one thing at a time, either solve one equation by multiplying it or adding it, and then add with your another property. Either if you are doing multiplication, multiply your first two properties, then multiply the answer of the first two properties by the second one. And similarly, if you have to find the right hand side of it, you will do like this. Okay, if it is about plus, okay, sorry. Okay, if it is about addition, you will do this, and if it is about multiplication, you will simply similarly multiply it by not having these addition signs, and you will simply have your answer of associative, you can say, addition and multiplication property. Thank you. That was about associative. Now we have a lot of cases here. We have, um, I can say, another case named as distributive property as well. And with that, we have additive quantity, multiplicative quantity. I can just define these. Okay. Now distributive basically means uh, similarly as I just taught you right now. Okay. And meanwhile, the associative was like the same. Okay, but the values were being multiplied there. Here the values are being um you can say distributed with each other. Okay, and additive quantity. Okay, now additive quantity basically means if I z is equals to 2, and if I add something in 2, that should give me the exact same number. That is my additive quantity. Now the additive word is here, my 0. Okay, if I'll do this, that'll give me 2 again. And if I talk about uh, the additive multiplicative identity, that is my 1. And if I do this like 2 multiplied by 1, that will give me what? 2 again. So 0 and 1 are my identities. Meanwhile, the 0 is called my additive, and the 1 is called my multiplicative identity. We will initially, we will proactively do this. We just initialized this way, not worked upon this with examples. We will do this in our next video. Thank you for joining me. Bye bye.